Hey, how are y'all doing?
Doing good. How about you?
Uh, Doing okay, but I get to adjust my volume now because you were quiet compared to, yeah. That's the weird thing when you do stuff with the computer and then like you adjust the volume and then you somehow show up in these virtual places and you can't hear anyone or they're too loud, perhaps. So I apologize if I shout at you. Things are going well pretty much. And hey, uh, here's the funny thing. I was reflecting on what would this class have been like in some ways had we been meeting in person on campus. Well, one is smaller. Two is that as a group, well, we'd be taking a test right now, okay? And it would be like a 2 hour test, and it'd be a 2 hours twice, 2 hours 4 times per week sort of class, and we would have, yeah. So I'm just saying I'm really happy that's not the case, even though online learning isn't always the best. When we get towards testing, it gives an opportunity to say, okay, hey, what questions do you have? And we can go through your questions, and then at your convenience, you can take the exams. So one thing I do want to sort of draw your attention to is an email that I sent out and something that I put into Canvas. And then I guess Willow's got a good question here as well. But I wanted to sort of share with you one thing administrative and then some questions. And uh-oh. Okay, so we'll talk about that in a little bit. And I think the answer to your question, Willow, well, I'm sort of sharing a desktop, is that that might have been attached to a textbook that was not the one that we're using. And I apologize for that. I tried to sort of take the labs that sort of work for what you guys are doing and match them up to what past classes have been doing. And because yeah, I didn't spot the linear model page 438. If it were important, okay, I if I will look through the lab and see, is this reference to a particular model actually important? But it probably isn't, and it's probably the model is just the regular regression model. And so I will write that one down for you here at the very bottom. Almost certainly it is the model where we've got yi. Oh, let's choose a color other than yellow. Yi is beta 0 plus beta 1 times xi plus epsilon I. Okay, that is the model what we have. And we believe the epsilons are normal in shape and a few other things. I'm not so worried about that because that's at the very last portion of the class. Okay. The key thing I would want to emphasize this term for you guys is there is a true population trend line with slope beta 1 and intercept beta 0, and we don't know either of those exactly. And because we don't know those exactly, even if you do know the X and Y values, you're not going to know the epsilon exactly. You will, however, be able to fit a trend line. The fitted trend line, if you will, from yesterday is Y hat. Y hat is beta 0 hat plus beta 1 hat times xi. And the beta 0 and beta 1 hat are the same as we did a few chapters ago. But the departures, the errors, if you will, the differences between what you would have predicted and then the true relationship, my residual, which is just the actual y value minus yi hat, you can sort of chunk that out piece by piece. And I'm going to sort of collect similar terms. That's going to be beta 0 minus beta 0 hat. That should be small. Plus then beta 1 minus beta 1 hat. That also should be small times xi. Plus then epsilon I. Okay, so the residuals will tend to be about equal to those epsilons. And so if you're looking into what the residuals are like, as a way of exploring whether the epsilons themselves are normal in shape, yeah, you can do that. We haven't emphasized that, but I wanted to, for the sake of completeness, mention that because you raised the issue. We do have some things, the requirements, if you will, of that normal linear model. Okay, again, the model in the lower left there. And if those things are true, we can do our hypothesis testing and all that good stuff. So I'm assuming that worked out for you, Willow, but you want to do a follow-up at all? Okay, you're cool. Cool. So let me sort of, I wouldn't say kill this, but sort of remove those hash marks. And let me sort of go into something that I sent out via email earlier, and I have a link to here, this grade calculator. And I'm not saying this is going to be something that all of you need to know and need to work with, but heck, why not? So I put this together to correspond to this term, and someone always, not just one person, but usually it's 4 or 5 people, sort of send me emails saying, hey, I'm a little panicky because here's my score percentage-wise, blah, blah, blah. And it doesn't net out with them receiving the grade that they want, okay? So here's a little tool that you could use that answers some, maybe not all of, but some of your questions, and let's show you how to maybe pull it off. So you put in your first exam score, let's say that was 81. Boom. And your second exam score, suppose that was 82. Yay. On labs, you've been getting 100% so far. And on the homework, because you're pretty good, you're going to get about 94%. So you put in your actual exam scores, put in the homework percentage-wise that you've been doing so far, and assume that on the last couple assignments that have yet to be graded, assume that you clock in at about that same rate. Okay. And that says so far you're at about 89.25% of the points, which is an A minus. Okay. I built in a few extra little bits of info because someone always asks me these questions in every single class I'm teaching. They asked the question, well, what would I have to get a higher grade in the class? And so I did that quick calculation for you. And yeah, literally, if you were to score 94.5 out of 100% across the 2 separate exams, okay, then your grade would be, instead of an A minus, it would be a solid A. Okay. If however you scored below 88.5% of the points on the final exam, then that's going to cause your grade to go down a little bit to, instead of an A minus, it would go down to a B plus. Okay. You can put in some hypothetical possibilities, like, what if I blew it off and just said, let's go for 60. If I aim for 60% of the possible points, I'm going to end up with 79.5% or a B minus overall. So that's a tool you can play around with. And 2 things to be aware of. One is the labs and the homework scores tend to be pretty high, and that may inflate your grade, if you look at just those 2, and don't keep in mind that the exams are tending to be a little bit lower. Usually the final exam percentage that a student ends up isn't dramatically below the exams, okay? It's usually at the exam score or maybe a little higher. If you think halfway between your exam score and your homework score, that's not maybe atypical. So 82 and 94, halfway between those 2 would be 88. So I'm going to put in 88 here. And that's a comforting grade of an A minus. Not so bad. Okay. And maybe if I, again, I'm sorry, no, that would be a B plus. Okay. And so it's just a matter of what is the score you're going to be getting? And you could plug in a variety of hypothetical scores just to see where you're likely going to end up at. Now, if you're the sort that gets like anxious by doing this sort of thing, limit yourself to like 3 minutes. It's not really that important compared to the actual spending time prepping for the exam. But as a tool to sort of help you know where you're at and remove the biases, if you will, that Canvas builds into place. Because again, labs, everyone gets 100%. You're going to get 100% almost certainly at the end of the term. Homework scores, they tend to be a little higher than the exam scores, but you know what? you could change that by doing really well on the final exam. So there will be two separate exams that are released at the end of class today. One is called Exam 3, and it's material that we've covered just since Exam 2. Then there's this comprehensive additional test. I don't know what it's formally named, but take the test. Maybe it's down here in the list of things to do. Aha, take the comprehensive addition to the final. Yeah. So those are questions that stretch across all three separate chunks of the course material before midterm one to midterm two, and since midterm two. And so across the comprehensive final edition, some percent of the points being attached to every single chunk of the material should allow me to assess your abilities on even things that we learned a while ago, and hopefully you haven't forgotten, but then even the more recent things as well. Okay. So I think that answers your question, Abe. Now, we're at a place where I prepared for you a sample final exam and answers. There are also questions you might have, administrative or related to recent lab activities or homework. Maybe let's talk about any administrative questions first, just because I always like to do that first, because otherwise they seem like really out of left field. Like in the middle of talking about regression and trying to do a confidence interval for a slope, and someone says, hey, how many points will the final be worth again? So let's talk about the subject matter stuff just a bit after the administrative questions, if there are any. Any administrative questions, please unmute now or type frantically in the chat. Okay, well, there's always office hours later today, which would be 5:10 till 5:35, and then also tomorrow at the regular Friday time slot, which I forget what time it is, but it's in the syllabus. Oh, I could look right here, 11:35 to 12:25. So show up then. And then also emails are a pretty good way of going in terms of trying to sort of grab my attention and say, hey, hold on, what about this? And again, emails that are allowed to, emails that allow me, I could say, to reply with my cell phone if I'm out and about, those are going to get quick replies. So make sure that you give me in the content of the email, so like everything I need to do, or to be able to refer to, like a quick screenshot of that one homework question and the work you've done so far, and your hypothetical. Here's how I'd approach the answer. Just type that out, so I could answer with yes or no. How about, and then, so if I could type a 1 or 2 sentence answer with a cell phone, you're going to get quicker reply than if it has to wait until later. Okay. So Chase asks, is there cutoff material for the final? Everything fair game? Pretty much anything we went over in class. Think labs, think course content in lecture, think homework problems. Everything seems absolutely fine, which suggests if you look into this last week, okay, you can fine tune the material you review, okay, in this last chunk of the term for the sake of your exam 3, and then the final comprehensive thing. Chapter 9, 1 and 2, yeah, 9, 3 and 4, good. 10, 1 and 10, 2, but not the rest of 10. And then more recently, 11, 1, 2, and 11, 3. But in 11.3, only inference about the typical value of y for a particular x. The confidence interval for the average y value, if you will, that we talked about at the end of class. The prediction interval approach, we showed you a picture of it, and y'all nodded inside your head because I could see you through the computer screen. You nodded inside your head, say, yeah, that seems reasonable. It's a wider range because we have to capture the variability. It's not just estimating the average y, but we wanted about what about a particular y? We need a bigger margin of error. Conceptually, that should make sense, but it's not something formally on your exam. Okay? So any other administrative questions? Okay, then how about content related to the lab from yesterday? Because that's, I think, a really good learning exercise. or homework related problems. Again, the homework problems assigned out of chapter 11, not actually due. You don't turn them in, but I'll be putting answers online later today for you to look over before you take the exam. Any questions on the homework questions from chapter 11 or the lab from yesterday? Okay, so with that in mind, I would love to comment on things that jump out at me when I look at the sample final exam. And these are not jumping out at me because, oh, yeah, I'm trying to hint at anything, but rather give you some insight into the mind of people who write the test. How do they do it? Why do they do it? What are these questions there for? Is this about as long as the test you'll face, etc.? So if this was an in-class final exam where we're meeting in class and you get 3 hours to do it, okay, come on. Boom, 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 boom. If you had a 3 full hours to do this test, this would be about the right length. Okay, this would be about a 3 hour test, meaning I write a test that I think a typical student should be able to be finished with and turn in 2 hours, but I'll give you the extra hour to do it. Again, final exam, if you work more slowly, that's okay. You can work more slowly on the final exam. A lot more material, so going slowly and being careful is probably a good way to read a bit. So this is sort of about the length of the 2 tests that you will together be facing. And so let me comment on individual things. And darn it, with the strikeout here, actually corresponds to the material in chapter 11, sections 1, 2, and 3 that we talked about just yesterday. So these, even though these questions are sort of stricken out, they're still valuable for the sake of studying. And every single one of those questions are questions that you could answer. Okay? Yes, you can. Okay. So I'm looking at this and I'm saying, like your Ninana ice flow problem, okay, predicting the date of the ice breakup, you might want to, well, in that case, we sort of know the trend is pretty clear, but you might want to test a hypothesis. How come they were crossed out? Well, because I accidentally used the exam from 2 years ago that I did with an in-class exam, and for that group of students, I told them don't so much worry about the chapter 11 content because we didn't cover it, and so I crossed it out for that reason. Okay, but for you guys, it's still would be good to review. So with the neon ice flow question, we could literally tackle the question: is there a statistically noticeable relationship between the date, literally in terms of number of years since 1900, and then the time of the ice breakup, or the date and time of the ice breakup? You could fit a trend line. Okay, I'll give you data if I have data to give you, and you could look for the p-value, and you could tackle that question just fine. Okay, and you could even do a confidence interval for the slope. Okay, confidence interval for the slope says how many days later, okay, how many days later is the breakup in the ice flow for every year that goes by. So how many days per year later is the breakup? And if I remember, the answer is like 0.0 tiny, but it boils down to across 100 years, 7 days earlier or so. Put a margin of error on that. That would be a confidence interval for the slope. You, however, might also want to tackle a question like, what would you say is the average ice flow breakup for, say, 2024? Actually, that's already in the past. We know that one. But if I was forecasting next year's ice flow breakup date, I could use the confidence interval method from yesterday and say, here's what I think the average ice flow break will be. It should be in this range of values. How many days since midnight of January 1st. Okay. So that'd be sort of the two separate confidence intervals. Do any of you want to ask about the two separate confidence intervals? Okay. So moving on into question two. Oh, I love question two. Okay. The reason I like question two is that it asks you to come up with something where you would say, okay, I have to invent my own problem. Okay. And yeah, just please don't, if you get this question or something like this on your test, don't just give me an example we used in class. Don't just give me something right out of the textbook, but rather in your own discipline, come up with something that might possibly be analyzed via regression. Okay, so maybe tell me, sir, how you would measure your explanatory variable, how you would measure your response. Maybe if it's in the context of an ANOVA, okay, where you've got this experiment where you're designing it, okay, describe the treatments. And if it's going to be regression could be used instead of ANOVA, the treatments have to be something numeric in nature. It could be maybe the dosage level of a drug that you give to someone. Okay. And so come up with your own question. Shouldn't take too long to do it. And it doesn't have to be in your discipline. It could be something very much that you just are thinking about. Maybe it's if you're a baseball fan, I don't know, I'm not. But you could say, is the amount that you pay a pitcher per year for the salary for that year, is that related to their ERA for the year? And that's, I guess, starting pictures, I should say, because the people that are brought in to close out the game, they're going to be a different kind of pitcher. But of the starters, is the amount they get paid related to their ERA? Do you see a trend in the ERA, either upwards or downwards, perhaps, as a function of the amount that you you pay them? You would certainly hope so, that their performance would be related to their salary, or hopefully based on their salary, that's going to be a way of buying a certain level of performance. If you're a Dodgers fan or a Giants fan, you know what I mean. Okay. Here's question three. Here's why I love question three. It's quick to freaking grade. Okay. But for question three, I know there are students who would say, I don't know exactly what the right answer is, but here's one that I think is reasonable. Yeah, literally in question three here, when I've graded it in a past class, when students used a method that is not the best one, but still isn't a laughable approach, I'm thinking, okay. As an example, some of you would say you should use a hypothesis test for a slope, okay, to tackle a question like, is there a relationship between the years since 1900 and the number of days since January 1st that the ice flow breakup occurs at the Nenana River in Nenana, Alaska? So is there a relationship? That's a hypothesis testing question. Yes, no questions are hypothesis testing questions. If you, however, said, hey, a confidence interval for the slope will allow me to do that, because if the confidence interval for the slope includes zero in it, that means zero is a plausible value for the slope. And if zero is a plausible value for the slope, maybe there is no relationship. So yeah, the right answer is a hypothesis test for the slope. But admittedly, a confidence interval is in the ballpark of correct. Okay. And then if you sort of were thinking maybe a t-test, because literally a hypothesis test is for the slope, is a t-test. It's not a two-sample t-test or a two-sample confidence interval, but because it is a t-test, some credit was given for people who answered t-test, and some credit was given for people who answered regression, if indeed the question is, do we have later ice flow breakup as we proceed forward across the decades in Nenana. Okay. And so you can see there's an opportunity for me to sort of grade algorithmically, check. Based on what you circle what you write out, it's going to be then quick and easy. These would translate pretty nicely into a multiple choice question, okay, inside Canvas, and those are auto graded. And if it's auto graded, uh, sometimes I have partial credit for other answers that aren't quite as good, and I always will look over later all the answers that you write out by hand and upload, because if I sort of see something you wrote out by hand that explains your thought process, I can better be prepared to say, okay, I don't get it, but because it's wrong, but yeah, I can see why you were thinking that. And even though wrong, it shows some evidence of understanding. So I'll give you partial credit for it. Okay. Easy to grade is sort of a really nice feature. Okay, so here's an ANOVA question, and it's sort of like the one that we looked at earlier with the broccoli, except we were talking about within one variety of broccoli, is there a trend across the not harvest times, the times that we dug up the broccoli, and we're looking at the root length. Here's the stem diameter across our 1, 2, 3 different cultivars. And so from just values like N, X bar, and S from each of the 1, 2, 3 groups, you should be able to recreate the whole ANOVA table. Yeah, let me re-say that by saying it again. You can create the whole ANOVA table from just N, X bar, and S for each of the groups that you're comparing. Now, I tend to shy away from questions where you're asked to essentially do that by hand. The reason is I like questions where I could just hand you the data set. Here's the data set. You do it. Okay. And you could run the analysis overall. Okay. I tend to like questions. I tend to like questions where that's the case. But sometimes I'll write questions where it's like A here. Hypothetically, how could you get your sums of squares treatment, which is 4.51140, from the numbers over here? Yeah, tell me an equation that allows me to translate these 6 numbers, or if you include the standard deviations, those 9 numbers over there, into sums of squares treatment. The notation I use this term is SSTR in the subscript. Okay. And I guess the students who sort of gave me the equation correctly, they could quickly do the verification. Yay. State your hypotheses. Whether it's in plain English or use symbols, you should be able to state the null hypothesis of no relationship, i.e. the same mean across the different groups. And if your p-value is, in this case, 0.62, you don't believe the alternative. We have no evidence here that there's a difference in the average stem diameter across the groups. Okay. So this question E is really getting after the issue of, do the ANOVA assumptions, are they holding? Do we really have the same standard deviation across all 1, 2, 3 groups? That is one of the assumptions of the ANOVA procedure, that all 3 population standard deviations are the same. And that's the one I wanted you to spot here, because literally 2 of the standard deviations are quite small, 1 and 1, and then one's like 5. The population standard deviations are not likely to be all the same if they produce these sample standard deviations. So the assumption of equality of spread isn't necessarily reasonable here. Moving on. Question 5. With question 5, I like it because it says, okay, you know about exponentials, and you know that, well, the mean is related to the variance somehow because it's an exponential distribution. And so if I tell you values like X bar, N, maybe S, could you come up with a confidence interval for the mean of the exponential distribution, the number that we're calling beta here? And some of you are thinking, well, the central limit theorem works. And so X bar plus or minus, I don't know, 2 times S over root N should work. But hey, hold on. there are other facts that are probably important as well. And one of those other facts is the mean is related to the variance. And so from just X bar alone, I should be able to have a variance term. Some other students actually even took the S value, which is related to the mean, because exponential distribution, mean and variance are related, and said, I'm going to use S as part of my way of estimating the value of beta. With the mean and the standard deviation, you have two separate things that both allow you some information about beta. And so any reasonable confidence interval would get great partial credit at least. And the one that follows the way our book would do it would get full credit. And I'm not saying go and look in the book because this is going to be an important method. The idea really is, though, if your distribution tells you some relationship between the mean and the variance, like with the Poisson distribution, the mean and the variance, they're related. We might be able to, from just the mean alone, be able to come up with an estimate, and the margin of error might even depend on the mean. And the process in our book where the author walks through deriving the confidence interval for a population rate based on a sample rate, where we end up with the n x plus 2 over n plus 4 approach. Looking in that section allows some insight into how these sorts of problems can be approached. But people who just pulled out the cookbook and said, I want to know the mean and my sample's large, check, and use the normal approximation central limit theorem and use S, they got really good credit. Okay. Chance of type 1 and type 2 error. That is one thing I would highly recommend you do consider. Review what is type 1 error and what is type 2 error. That's something that I did not emphasize enough in class for my own taste. So let's give you type 1 and type 2 error. And let's do this in the context of the range of possibilities. Okay, there's a range of possible outcomes and truths. And so I'm going to say things like, well, what if the truth is the null hypothesis? Maybe the truth is the alternative. There is a truth. And because they're logical opposites, it's either one or the other. Okay, and we could either reject the null hypothesis or we could refuse to reject. Okay, so don't reject the null hypothesis. And so if the null hypothesis is true and we don't reject it, that's sort of a good outcome. I'll make a little happy face. Yay! The null was true and we didn't reject it. Okay. What about if the alternative is true, but we rejected the null? Again, we hit the right conclusion. We're happy. Okay, if the null was true and we rejected the null hypothesis incorrectly, if you will, a false positive, that's sometimes termed a type 1 error. And a type 2 error is going to be if the alternative is true, but you don't spot it as true. You don't reject the null hypothesis. You stick with the null belief, even though the alternative is correct. Okay, so these errors, depending on your discipline, have names that are maybe even cooler than type 1 and type 2. If you're sort of into drug testing, and that came out wrong, if you work for a drug company or a company that makes medical devices, you will sometimes deal with sensitivity and specificity. Those are other names for type 1 and type 2 errors. Okay, I'm thinking to myself, you might want to logically consider what would a type 1 error mean and what would a type 2 error mean, and which one of them is actually more dangerous. Is one of them maybe going to cause people to die and the other doesn't? Here's an example of a problem. What if there's a drug out there? Actually, not a drug. Hold on a second. Okay, I've forgotten the exact thing it is, but let's suppose it's a drug, and we'll call it drug X. And drug X could reduce your risk of death from diabetes by 1/3. That sounds like a huge win, yeah? If there really is the null being true, okay, If the drug doesn't help, but you think the drug reduces a person's risk of death, that will cause people to, well, make this drug and then buy it and use it, even if there's no benefit. That sounds like a bit of a problem. What about the other case? What if the drug actually is super helpful and would reduce your risk of death by diabetes by a third, but we don't spot there is a benefit of that drug? There are people who could have their lives saved, but won't because they're not taking the medication. They have different actual implications for real life. And so, depending on whether type 1 errors are bad or type 2 errors are worse, you might very well want to say, okay, I don't care about type 1 errors, but type 2 errors are really horribly bad. If that's the case, you might be willing to take a higher risk of a type 1 error. You might be willing to compare to an alpha of 0.1 instead of 0.05. Because if you lower the rate of a type 1 error, I'm sorry, if you raise the rate of a type 1 error, you're going to lower the chance of a type 2 error. Okay, so reviewing type 1 and type 2 errors recommended. Okay, back into the sample exam. Okay, I think covered a lot there. Oh, yeah. Here's a problem where someone always during political season, and geez, isn't that every year now? Someone always during political season says something about, oh yeah, this party is better than that party for this reason. And I think the way it made it into the news in the last few months that I've heard is voters believe that the Republicans, thus Donald Trump, is going to be better for the economy than the Democrats, that is Kamala Harris. Whether that's true or not, I don't know. So at one point in time, I looked into data that talk about this question. And well, we're going to define a low increase in the national debt. Okay. And we have a low, medium, and high. Low is defined, medium is defined, and high is defined. Okay. So there's low, medium, and high, L, M, and H. Okay. And then we have so Republicans and Democrats. And I guess if I had R's and D's and then L, M, and H, you would want the party you support to be able to say, oh, the increase in the national debt has been low when my party's been in charge nominally in the presidency in some way. Okay. So the data values here basically tell you, okay, 13, 5, and 4. And we've got 5, 4, 10, and 10, and 13. And that reads a little bit different than what the polling data suggests people in general believe, but that's the data, at least during a time period when I collected. These are data that capped out about 2 years into Obama's first term. Okay, so since then, maybe the pattern has changed considerably. But walking you through, can you do a categorical analysis? So yeah, oh, chi-square. At least you should remember 2 things. 1, okay, categorical explanatory variable, categorical response. Oh, that's got to be chi-square. Okay, and because you know it's chi-square, you should have an equation sheet right out in front of you. Literally, I highly recommend for this exam preparing not a cheat sheet, but a set of notes that you'd want to have on 8.5 by 11, 1 page or maybe 2, that would allow you to quickly identify. So if I can tell you the name of the method, or if I know whether the explanatory variable is quantitative or if it's categorical, do I know what method I should be using? Across a t-test, a paired t-test, confidence interval for each of those cases, a chi-square, and then a confidence interval for binomial proportion, and then a regression, and then ANOVA, and there's lots of methods. So if you know it's a question that asks you for a conclusion based on data, it's going to be one of those recent methods that we've talked about. Which one is it? Based on the nature of the data, okay, what the data are like, you can probably quickly know what the method is going to be. And so there's usually an explanatory variable and a response variable. And the explanatory variable is either categorical or it's quantitative. And the categorical variable either has just 2 levels or has 3 or more. And the response variable is either categorical or quantitative. And so let's go through the list of the possible methods. Not a complete perfect list, but if our explanatory variable is categorical with 2 levels in the quantitative response, you're thinking a t-test to compare 2 different groups. ANOVA compares 3 or more means, okay? And if you've got quantitative, explanatory, quantitative response, you're thinking regression. Okay, no problem. We got those down. What if your explanatory variable is categorical and your response is categorical? You're thinking chi-square. In both of those 2 cells, chi-square is the appropriate way to go. And although we didn't really focus in on it, logistic regression. That's not something our class is dealing with, and so you wouldn't have to worry about that. But this is the bulk of the statistical methods that we've got. If there is an explanatory variable and a response variable, it's going to be one of these 1, 2, 3, 4 methods. How do you know which one it is? Explanatory and response variable. Tell me whether it's a number or not. Tell me whether it's a group or not. Okay. Okay. Let's get back into your chi-square friend. Okay, so here's a fun question. C. What if I told you the actual chi-square statistic? Notice that I'm not saying go through for every one of those 6 cells, find the expected count, then find observed minus expected, then square, then divide through by expected, then add all those up. I just did all that work for you. Okay, so yeah, literally, if you've got this chi-square context, you might very well be given a chi-square value, and from that you could get the conclusion. Or like in one of the labs, you could say, let's go ahead and type the data values, the counts in each cell into a column of frequency of occurrence. And we could use, like in the lab, the chi-square approach inside fit y by x. It should be fine. Okay. And then I like D. D asks you a conceptual question, like, yeah, literally, what would it even mean if the observed count was higher than the expected count? Okay, what does that mean? So let's change it up a little bit. And I earlier said the increase in debt was low or medium or high, L, M, or H. Well, what if we worked with the number itself instead of the categorized version of it? I've got R's and D's, and then you got an average increase in the national debt during the term of that particular president. And so we've got also standard deviations. I got N, X bar, and S, and I could from that create an analysis. So maybe I would give you just the data summaries, maybe just the t-test output, maybe both, okay? If I give you both, it's going to be a different sort of a question than if I give you just the data summaries, in which case, you're probably going to have to do some calculations. But you might be asked to provide an equation, put in some numbers to verify, okay, your T ratio here. Okay. So, confidence interval. This says do a confidence interval. So you state an hypothesis test. There's a lot of things I could ask you about. The key really is, in plain English, if you want to know what is the benefit of having Democrats versus Republicans in the White House, from the point of view of the increase in the debt, the benefit is the difference, okay? And that would be with a confidence interval. You tell me how much lower the increase in the debt would be in one group than the other. I'm going to say, is there a benefit? That's going to be a yes, no question. It's going to be a hypothesis test. And knowing all the parts is going to be helpful. Oh, here's a fun question. Hey, what if I have a margin of error? Could I solve for the n you would want? Could I solve for the n that you would want? So let me sort of remind you of an approach to tackling that problem. If I told you my confidence interval is x bar 1 minus x bar for group 2 plus or minus t times the root of S1 squared over n1 plus s2 squared over n2. If I want to know the sample size needed to get a target margin of error, and let's call that a bound on the margin of error B, if we're willing to assume n1 equals n2, and I just call that common value n, that might not be the case. We could talk through variations on that later in office hours if you'd like to. But if I'm willing to assume that n1 and n2 are both the same, I could find n in terms of p, b, s1, and s2. And so it's a matter of plugging in the value for t for the confidence level you want. Use 2 for 95% confidence. Plug in the bound you want there on your margin of error, and then an S1 and S2, and it'll tell you about how many Republican terms and how many Democratic terms you'll need to see. The total sample being twice n, we're going to get at least in the ballpark if you tell me how many years or presidential terms you need to wait to get that target margin of error. Okay? Okay. Last question is E, and I think that's sort of a fun one to consider. What if you're not willing to assume normality and our sample sizes of like 20 and, well, not quite 30? Okay. Some people say, 25 and up is good enough. Other people would say, I need to look at the distributions. Statisticians tend to be in that group. I'm trying to think. You algorithmically, as students are told, n needs to be 30 for each group, or n needs to be large, like at least 25 for each group. And if you don't have that normality that would allow you to feel comfortable to use this method, could you use the chi-square approach that we had just used above? And that seems to be actually something that would be valid, because with the chi-square approach, where we took our actual increase in debt and numbers and categorized every single presidential term into low or medium or high. Okay. Actually, this is each year, I think, because 50 years of 50 presidents, we barely have had that many. Okay, so this must be per year. Okay. The question really is, can you use a categorical thing where you take your quantitative variable and chunk it into categories and just say, hey, what percent are in this group, this one or that one? And the answer seems to be, from question 6, yeah, you can. So if you ever have a analysis method that needs normality, and you don't have that normality, just know there is something you can do to probably work around that problem. It just might take a little bit extra work, and it might be a little less powerful. Powerful, again, meaning the chance of spotting a real trend, if there is a real trend. The chance of spotting a trend is real if there is a real trend. I should say it that way. So the statistical power is, how likely are we to spot a difference between Democrats and Republicans if there is one? The chi-square approach upstairs in question 6, less powerful than the t-test downstairs, but it doesn't have as many assumptions. And in that same regard, all of our statistical procedures, they have assumptions behind them. Sometimes they work, sometimes they don't work. And if they don't work, there's always a backup plan. Even if it's not in our book, there is a backup plan somewhere. So it's a good thing to know, statistician. A good friend of mine says, when I was in grad school, I didn't know anything about statistics, so I was sure to know a good statistician. And I'm going to recommend, for those of you who are going to collect data at some point in time as part of your graduate career, or working as an employee somewhere, get to know a statistician. Because if you are collecting data or analyzing data that someone else collected, you shouldn't just trust what that other person says is the right thing to do. Actually ask someone, is this the right thing to do? Ask a pro. It's like doing plumbing at home by yourself. Yeah, I can go to the hardware store and say, okay, what should I buy? But if my toilet later explodes, I sort of regret that choice. Okay. Talk to a pro, hire in a pro if you need to. I'm going to stop the share now and say, that's it for me for the term. one thing I want to mention is I'm intending to send out a survey to y'all that asks a couple questions like, hey, how did this part of the class work for you? If you had to redesign it, how would you do it? You know, that will allow me good information should I ever be lucky enough to teach a summer 312 online again. So I want your input, and I'm also going to ask you a few other questions about, you know, would you've even signed up if this had been on campus or etc. Good place to stop. Enjoy the rest of your day. We will see you in the future, we hope. And because I don't know what any of you look like, if you do see me on campus, wave at me. And then when I look at you like I don't know who you are, say I was in your 312 summer class. It's good to meet you. We'll see you soon. Bye bye.